Hi, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Already we discussed about the diagonalized matrix up to in the diagonalized matrix we got lambda values from the given matrix lambda equal to 0, 3 and 15 up to case 1, that is lambda equal to 0 we derive, and next in this video we are continuing with the lambda equal to 3 value. So next value we can calculate lambda equal to 3. So here instead of that lambda, if we substituted in, we got the diagonalized matrix 5, 4, 0 alone will change. So these values we got it. So here we got the three different equations. So we can move on. We can choose any two rows. So from this two rows, I am choosing first two rows. So 5 minus 6 minus 6 4 2 minus 4. These two rows we can choose. So in this row we can write the using cross multiplication method we can write the values x1 x2 and x3, all the values x1 x2 x3, the first two, next two and then next two. If we go like that we can multiply and we get the answers for these terms. So from this we got the values of x2 is 2 1 minus 2. So these values we got. So next same thing we can move on to the lambda equal to 15. So if we substituted lambda equal to 15 in the diagonal we got. So the diagonal values are minus 7, minus 8 and minus 12. It is changed like this. So if we check these equations, these three equations are different equations. So easily we can move on to the cross multiplication method. So for the cross multiplication method, first two rows we can choose. In this two rows we got the final x3 value as 2 minus 1 1. These things and we already discussed earlier. So we continue with these values how to do. So from these three eigenvectors, I am writing the model matrix. The model matrix is first x1 vector and then x2 vector and then x3 vector. So these three vectors we are writing as a single matrix value. So these three once we wrote means next we can calculate the normalized matrix. The normalized matrix means nothing, it is the normalization each column of vector m and dividing each element of first column by 3 and second column by 3 and the third column by 3, we get the normalized matrix. Nothing it is that in the normalized matrix these three values we are using. So square root of 1 square 2 square plus 2 square. Conclusion of these values taking a square root got the answer as 3. So this denominator this conclusion of this value we are writing in the denominator and we got the normalized matrix here. So after this all the values first row, second row, third row, all the values are more or less same. There is 1 2 2 only we got. So everything is got the denominator as 3. We got the common denominator, so we can choose the common denominator outside the remaining matrix we got. So next step is to calculate the next step is to calculate the diagonalized matrix. For the diagonalized matrix formula is n transpose an. So first we want to write the n transpose. So normalized matrix transpose we are writing and then we multiplying all the values n transpose A matrix and then n matrix. All the three matrix we are writing together, and if we multiply first we want to multiply first two matrices and then with these two matrix we can multiply with the third matrix. if we multiply it all together and divided by this 1 by 3, 1 by 3 means 1 by 9. If we multiply it all together, we get the matrix 0, 3, 15. Only in the diagonal values, the remaining and all is 0. That is, we get the diagonalized matrix. So, this is the conclusion for this sum. So, this way we can calculate easily the diagonalized matrix. Thank you.